Dear students, welcome to the problem solving session number 1 in the level 1 of the chapter of chemical bonding in physical chemistry. So in this problem solving session we shall be doing the problems which are very important as per your board levels are concerned, or which gives you understanding about the basic concepts of the chapter of chemical bonding. So we start with the problems that are there. So the first question of the day is, explain the formation of these four molecules. So the molecules that are given are sulfur dioxide, then there is sulfur trioxide, then there is ammonium ion, and then there is hydronium ion. So this is H3O plus, this is NH4 plus, this is SO3, and this is SO2. Now we shall be drawing the structures of each of them, and side by side we shall be explaining the formation of these particular structures. So we start off with sulfur dioxide first. So first is sulfur dioxide. In sulfur dioxide, we can say during the formation of such a molecule, the sulfur achieves its octet by forming two covalent bonds with one oxygen atom, giving SO. The sulfur atom in SO has two lone pairs, one of which is shared with a second oxygen atom to form SO2. So this is the basic theory through which we can explain the formation of the sulfur dioxide molecule. So here we can draw the diagram based on such an understanding. So here you have oxygen with 6 electrons in its outermost shell, and there is sulfur which has also 6 electrons in its outermost shell. Another oxygen lies sideways, which is containing 6 electrons in the outermost cell. So let us now find how the bonding occurs. So as it has been already said that the sulfur achieves its octet by forming two covalent bonds with one oxygen atom, giving rise to SO. So here is the formation of the covalent bond that take place. There is the presence of a lone pair, and this particular lone pair is shared with another oxygen atom, giving rise to SO2. So the structure of sulfur dioxide now stands as follows: that you have oxygen then there is a double bond, then there is a sulfur. These two electrons are forming the double bonds, and one electron is now donated to the oxygen atom, or one lone pair of electrons is donated to the oxygen atom, and thus it gives rise to the molecule of sulfur dioxide. So this is how we can explain the formation of the sulfur dioxide molecule. Now our next query was that of the sulfur trioxide molecule. In order to explain the sulfur trioxide molecule, let us have a look at the molecule of sulfur dioxide itself. If we have a look, we can find that the sulfur atom in SO2 has one lone pair which it can donate. So we can say that this lone pair of electron is donated to the other oxygen atom, or a third oxygen we can say, giving rise to the sulfur trioxide molecule. So this is the basic understanding of the formation of the sulfur trioxide molecule. We have already discussed in detail how the molecule of the sulfur dioxide is formed. Now if you have a look at the structure of sulfur trioxide molecule, it will be like this. So there is an oxygen, there is a sulfur here, there is oxygen out here, and also there is a third oxygen containing 6 electrons in its outermost shell. So there is a formation of a double bond here. This lone pair is donated to this oxygen, and this lone pair is donated to another oxygen. So there is the formation of the sulfur trioxide molecule ultimately, and what we have such kind of structure. So this is the molecule of sulfur trioxide. So I hope you have understood how the formation of sulfur dioxide and the formation of sulfur trioxide can be explained. Going back to the question, we have discussed these two, sulfur dioxide and sulfur trioxide. Now we shall discuss the formation of the ammonium ion and the hydroxonium ion. So this is the ammonium ion and this is the hydroxonium ion. In the formation of ammonium ion, this can be regarded as a combination of NH3 molecule and a H plus ion. So ammonium ion or NH4 ion can be regarded as a combination of NH3 molecule and H plus ion. In ammonia molecule or in NH3 molecule, we can say that the 3 hydrogen atoms are linked to the nitrogen atom by a covalent bond. We all know that ammonia has a pyramidal shape, as we have already discussed. Now, there is a lone pair of electrons on the central atom nitrogen in ammonia molecule. So this lone pair of electron are donated to the H plus ion, and thus there is a formation of NH coordinate bond, and the formation of NH4 plus ion can be explained. So let us draw the diagram. So you have 3 covalent bonds with nitrogen with the help of 3 hydrogens. There is a lone pair that is there on the central atom nitrogen. It is donated to a H plus ion, and there you have the formation of the NH4 plus molecule. So this is the NH4 plus ion. One thing is to be noted, it's a kind of a Lewis acid Lewis base reaction, the formation of ammonium ion. Here ammonia, which has a lone pair of electron, is an electron pair donor. So this can be regarded as a Lewis base, since a lone pair donor is a Lewis base, and a lone pair acceptor can be regarded as a Lewis acid. So H plus can also be regarded as a acid according to the Lewis concept. After the formation of ammonium ion, the 4 NH bonds become identical, and hence NH4 ion can also be represented with the help of this structure. So once the NH bonds become identical, we can say that there is a formation of this ammonium ion. Now after this discussion about the ammonium ion, we now move on to discuss about the hydroxonium ion or the H3O plus ion. Kindly note the spelling, it's hydroxonium ion. The hydroxonium ion is formed by the association of H plus ions with the neutral water molecules. So if you have oxygen like water molecule like this, this will